So we can write B as mu naught I d over 4 pi, and value of this integration can be found by this formula where a is equal to d and x is equal to c. So this formula will become x is equal to z divided by a is here d square and d square plus z square 1 by 2, and a limit from minus L by 2 to plus L by 2. So this B becomes mu naught I, and 1d is cancelled in this d, and remaining d we take out, we write here 4 pi d, and here it becomes z over d square plus z square 1 by 2, and a limit from minus L by 2 to L by 2. So if we put limits, then B will become mu naught I over 4 pi d, and here first upper limit L by 2 instead of z, and this will become d square plus L square by 4 whole power 1 by 2, and minus L by 2 divided by d square plus L square by 4 whole power 1 by 2, and this will become mu naught I over 4 pi d, and this will become, if we take LCM, that will be d square plus L square by 4 whole power 1 by 2, and this will become L by 2 plus L by 2, that will become mu naught I over 4 pi d, and this will become L d square plus L square by 4 whole power 1 by 2. And if L is very large, for example, if we say that L is very large than D, then this term becomes 0. So this will be equal to mu naught I over 4 pi d, and L by, this will become L by 2, so L will be cancelled, and this will become mu naught I over 4 pi d into 2, this will become 1 2, and this will become mu naught I over 2 pi d. So this is magnetic field produced by any line segment. This is the result. So this depend on the current carried by the wire and a distance from the wire. We have already derived such expression when we had a line charge. So in that case also electric field varied with the single D, and in this case also magnetic field varies with I and a single D. So if we want to find now the mathematical solution when we have two wires that are parallel to each other. Previously we discussed these wires qualitatively, but now we will discuss these wires mathematically. So mathematically, for example, this wire carries current I1 and this wire currents I2. So its magnetic field at this location will be invert. It will produce its B field B1 here. So when it will produce B field here, so this B1 will exert force on this wire towards this. That force, for example, we say that F21, force on 2 by 1. So that force will be given by F21 I in the wire 2 and a B of one wire and a length, for example, length of this wire is L. So that will be given by L. So the B that this wire produces here is given by the expression that we have already derived, that is, for example, distance between them is D. So that is mu naught I over 2 pi D. So the magnetic field produced by this wire at this location B1 will be equal to mu naught I1 divided by 2 pi D. So if we put here F21, that will be equal to I2 mu naught I1 over 2 pi D into L. So this will be F21 equal to I2, here I1, so mu naught over 2 pi D. And if we take this term to the left side, then this will become L. So force per unit length will be equal to, given by this expression mathematically. And if we consider the force on first wire, the expression will be the same. Okay.